Hi, good evening. This is a video on like terms and simplifying expressions, page 20 in your notebook. So let's go ahead and get started with our notes portion. So the very first section is talking about what like terms are. So we're going to fill in that top row of blank spaces. So like terms are a set of terms that have the same variable So variables are like letters that we use, X, Y, Z, A, B, C, raised to the same power. So they have to have the same power in order for them to be like terms. So we're going to think of the variable as the first name and the power as the last name. Like of a person. And then X can kind of be like a regular candy bar, and then X squared is like a king size candy bar. So we're not going to combine those together because this has a power of 1 and that has a power of 2. So that's just kind of a cute way to remember it. All right. So let's go ahead and look down here. So we have 2 and 3. Both of those are constants. So they have the same power and they don't have any variables. So they actually are like terms. So yes, they are. 3x and 2x, they both have an x and they're both the same power of 1. So we can combine those and it actually would make 5x. So yes, we can combine these. So are they like terms? 4x and 4y. So they are different variables. So therefore we cannot combine them. So it's going to be a no. 5AB and 6AB, that means it would be 11 ABs. So I can combine them, so that's going to be a yes. 16x squared and then 6x. So they do have the same variable, however their powers are different. This is a power of 2 and that's a power of 1, so no, we cannot combine them. And then 9xy and 7yx. Technically, if you remember last night, multiplication is commutative, so we could actually change the order of this to 7xy, which would then which would then make them have the same name. So yes, we can combine them. Okay. All right, we're going to move down here, and then we're going to circle all the like terms that are in each of the following sets. So looking here, do we see anything that's alike? The 5x, the negative 6x, and the x. I'm not going to include the 3y because that's a variable of y. I'm not going to include the 4x squared because that's a power of 2, not a power of 1. All right, in this set, do I see anything that's alike? I've got constants. So I've got 15, 3/5, and 1/10. So those are all constants, which are like terms. I can combine those. Here, I'm looking for the like terms, and it looks like I've got xy, I've got 9, technically I can change the order to 9xy, because remember multiplication is commutative, and then negative 8xy. I can't put these two together because that's a x squared y and that's a xy squared, so those are actually different than each other. And then this fourth set, this fourth set, what I can combine looks like the negative 5a squared b and then 3a squared b. Okay. All right, so what I would like for you to do is go ahead and complete these 4 and then tell me why you said yes or why you said no. And this starts getting a little loud because class changes are happening right now. So let's open up to the inside page, and we're going to talk about combining like terms, so actually putting them together. So combining like terms is the process of adding or subtracting like terms together. Simplifying just means that you're combining like terms. So you might have more than one set of like terms, and so therefore you simplify. And you're going to simplify until all the terms are in their simplest form. So here's a checklist of how you can combine like terms. So make sure that when you group like terms that they're with their signs. So if you see a plus sign in front of it, it's positive. If you see a subtraction sign in front of it, it's going to be a negative. So that kind of integrates the integer portion that we learned in Unit 1. Here's just some tips that you could use. You could put a circle around the first group of like terms, a rectangle around the second group of like terms, a triangle around the third. I personally like to underline because it takes less time, but we can do the circling and the rectangles and triangles if you'd like. So let's look at example 1. So 5x, x, and x, they actually all are like terms, so we're going to combine them. So this is 5 plus 1 plus 4, which will give me 10x. Over here, these are alike because they both have an xy. So this is 10xy, that's 7xy, so it's a total of, and it's addition, 17xy. I've got 5x squareds, I've got 7x squared, so I've got a total of 12x squared, so those are also alike. This one gets a little bit different. So not all of these are the same. So I'm just going to circle the ones that can be combined, which would be positive 4x and positive 3x, which would give me positive 7x. And the 8y can't be combined with anybody, so we're just going to bring him down, and he's a plus 8y, so I'm going to make it plus 8y. And this is actually your final answer. It looks funky, it's just called an expression. It's an algebraic expression, and that is your final answer for example 4. All right, I want you to go ahead and try the rest of these out. I will go ahead and help you out with number 11, because that one looks a little tricky. So let's jump down to 11. I want you to do these, though. So let's look at 11. So it looks like 6x cubed and 10x cubed can be combined. That's a positive 6x, that's a positive 10. So that gives me positive 16x cubed. And then I have a 9x and then a 4x squared, so those are not even alike. So I'm going to put a box around this one. And then I'm going to put a triangle around this one because that's even different than the other ones as well. And it's positive. So that's my final answer. So here is my 3-term algebraic expression with 16x cubed plus 4x squared plus 9x. Okay. And then over here, I want you to practice the same thing, but please notice it says combining like terms and distributive property. Distributive property is when you take a number on the outside of parentheses and you multiply it by the inside. So let's do a quick review of that just in case. So if I had 3 parentheses 2a plus 1, I would distribute the 3 onto both pieces on the inside because it's saying I have 3 groups of this. So 3 times 2a gives me 6a, and 3 times 1 gives me 3. So that's just a quick review of distributive property. And then integers, remember integers are positive and negative whole numbers, so please notice how these are starting to get a little bit more complicated than the previous page, so be very careful. So for example, number 1, 6y plus negative 13y. Well, we know that these can be combined because they are like terms, but this is positive 6 and that's negative 13, so that's going to give me negative 7y. Here, I've got negative 12 plus negative 9z, so they're both like terms, and since I'm adding the same sign, I'm going to find the sum, so I get negative 21z. I'm going to move over here, so I've got negative 8x plus 9, I'm going to go in order, so it will give me 1x. And then 1x take away 13x. Well, 1 take away 13 is negative 12. So I get negative 12x. Okay. It looks like that the rest of them are pretty similar. Let's jump down here to number 14 where you have to use distributive property. So 5 times 3e and then 5 times 5. So this gives you 15e plus 25 minus 25e. Let's circle any like terms that we have. And then did you guys notice how I circled the minus sign with it? And that so that I know that this 25 is actually being subtracted. So I don't say 15 plus 25, I say 15 minus 25. So be very careful when you're doing this. So 15e minus 25e is actually negative 10e. And then plus this 25, because that's the constant, I can just put that right here after. So this box right here is my final answer. All right, so the rest of your homework is to go ahead and try the rest of these. Some are going to be super quick and easy. Some are going to take a little bit more time. But if you have any questions, please leave a comment on the video or ask tomorrow in class. All right, good luck and have a great night.